Hi, my name is Pranav Varshni, and this is my EECS 203I application. So, in discrete mathematics, we have this topic called Bayes' theorem, and the topic today is we're going to be going over like Bayes' theorem and how it applies to conditional probability. It's important to understand that this is only used for conditional probability and not independent systems like coin tosses or dice rolls. So let's kind of look at what the formula is talking about and kind of how we can read it in English. This P of A bar B is said in English as the probability of event A occurring given we know what probability or like event B is. And we can kind of see that with this question from Discrete Maths 8th edition, question number 3. Suppose that Frida selects a ball by picking one of two boxes at random. This is very important to like read and understand. Like we're picking two boxes at random. This random means that we have like a uniform distribution. So that means the distribution or probability of picking either box is equal. This could very easily have been like box A is 40% and box B is 60%. So it's very important to kind of like read and understand that. The way that I like to tackle these problems is by drawing some sort of like story or decision tree where the conditionality kind of builds as we go from left to right. So let's kind of draw that out really quickly. We have a starting like node or position or whatever here. And from here, we can either go to the first box or the second box. And the probability for each is just 1/2, right? Because it's at random and we have two different things. So it's 1/2. So we have second box right here. Let's keep reading. And then she selects a ball from this box at random. So now we know that these boxes have balls inside of them that Frida will be picking in the future. Let's just move this down here to make more space. So in that case, we're kind of like seeing how our story is compounding from our left to right. In the first box, we're going to have some more arrows based off of what we have. We can see here that the first box contains 2 white balls and 3 blue balls. So that's a total of 5 balls, and we have 2 white and 3 out of 5 blue. So right here we have the white ball or the blue ball. White was 2/5 and blue is 3/5. The same thing is true for like the second box, but in this case, the second box has 2 white balls and 1 blue ball. So let's just draw that down here. White and blue. Blue. White is 4/5 and blue is 1/5. So that's kind of it for setting up our like decision tree or like the tree that maps everything out. This is very important and very like important to understand and intuit because this is going to do a lot of the heavy lifting that we have remaining. So based off of that, like what exactly are we trying to find with this question, right? So what is the probability that Frida picks a ball from the first box if she has selected a blue ball already? So that can kind of tell us like what exactly the condition is and how we're supposed to be building the problem. So we have the probability um, of the first box given a blue ball is equal to the probability of a blue ball given the first box times the probability of a first box divided by the probability of blue. So this is kind of just following Bayes' theorem, following the mathematics and the formula itself. But kind of how do we figure this out? The probability of us finding a blue ball given that we're in the first box. So we're starting off here, like at this place, and we're reading from left to right. We can see that that's the probability is like 3/5, right? Just intuiting it based off of the tree that we have drawn. Second is the probability of us picking the first box. That should be pretty easy, right? There are only 2 boxes. They're at random, so the probability of picking one box should be 1/2. Now, the probability of picking a blue ball is where we have to consider these two separate like boxes or these two separate systems together as one. So we can see that each box has 5 individual balls for a total of 10 balls. We know that in the first box we have 3 balls, and in the second box we have 1 ball, looking at the numerator. So that's just 3 plus 1 means we have 4 total blue balls out of a total of 10 like balls in general. So the probability of picking 1 blue ball in the entire system is 4/10, right? Now we have like our Bayes theorem kind of situated and solved entirely. We just have to do some basic arithmetic. So we have 3/5 times 1/2, which is 3/10, divided by 4/10. These tens just cancel out, and we have 3/4. Let's just check that with what I did in fall 2023 when I was taking the exam. And you can kind of see, pause the video and just look at the diagram. We know that the tree evaluates to the same thing, 3/4. So that's kind of how we intuit these base types of problems, just drawing the tree and making sure that it's pretty intuitive and it makes sense.